Okay, in this video we're talking about Newton's third law of motion. To get you guys kind of started off talking about this, we're going to watch a little clip from Khan Academy. This one is actually called LeBron Asked About Newton's Third Law of Motion. So let's start this real quick.
Newton's third law tells us that to every action there's always an equal and opposite reaction. When I'm shooting the ball, I am clearly applying force to it. Where is the equal and opposite reaction?
Okay, so after LeBron asks this question, Sal Khan kind of gets into explaining where those forces are acting. And he kind of draws it up here. We got LeBron James. He's been explaining it a little bit. He says force applied by hand on the ball, so that one's going in this direction. So his hand's actually applying a force in this direction. And then force is applied by the ball on his hand. So in his explanation, Sal Khan starts asking, why, whenever he's applying a force to the ball, if there's an equal and opposite force on his hand, why does his hand not fly back? So the ball is flying forward, correct, but his hand doesn't fly back. And so he starts talking about the muscles. So there's a forearm muscle that keeps it from going back, and then there's a tricep muscle. But he really doesn't get into the actual answer to the question, I don't think, which is really the difference in mass between the two objects. So I asked you guys in class, does mass play a role in the interaction? And yes, so for every action there's an equal and opposite reaction, which is Newton's third law. You still have to factor in mass. So the answer to this question is really the ball weighs very, very little, and then LeBron James weighs a lot more than this ball. So you have to take into account the difference in mass between the two objects. So for instance, let's say that he applies, and I'm just making up a random number, say he applies 20 newtons to the ball. Well, the ball is going to apply 20 newtons back on LeBron's hand. 20 newtons, it would be plenty of force to make the ball go forward, but since LeBron's so much bigger, it may take 200 newtons to get him to move back a little bit. Because of the difference in mass. So mass does play a role in these interactions. Okay, so let's look at the actual definition a little bit. When one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Okay, so this is kind of a counterintuitive idea a little bit, because usually, like for instance this example here, if you're applying a force to the wall, you're pushing on that wall, you might think of you actually applying a force, but you don't actually think of the wall applying a force back. You'd never just say, oh, the wall is applying a force back as well. But because you're pushing on there, say you're pushing with 20 newtons, that means the wall is pushing back with 20 newtons also. It's always going to be equal. Depending on the mass of those two objects is going to determine which object's going to move. So this wall, if it's a lot heavier than this guy, the wall's not going to move. He's going to push himself back in that case. Usually we talk about, in Newton's third law, we talk about action-reaction pairs, or just reaction pairs, however you want to say it. So that's what we did in the lab today. And usually I might ask you guys questions. What's the action force? So that would be like the first force being applied. So this would be like the person applying a force to the wall. The reaction force would be the wall applying a force back onto your hand. So this one, basically anytime there's two objects touching, this law applies to that. Because if you apply, or if two objects are touching, they're going to apply forces to each other. And so you're always going to have that equal and opposite reaction. It also explains how rockets work a little bit. So in class, we're probably gonna build some rockets and then shoot those off. But to kind of explain how this works for a rocket, well, a rocket obviously is going to be moving in this direction. So the momentum of the rocket is moving upward. The force of the rocket on the gas, so it's expelling gas out at the bottom. So there's some kind of explosion causing that gas to expand really rapidly, and there's going to be an opening at the end letting that gas out. And so the force of the rocket on the gas is going to be going down. So there's probably something stopping that gas from keep going up, and it's got to go down out the bottom of it. So the force of the rocket is going down. The force of the gas on the rocket is applying that force up, causing the rocket to go up, and then the momentum of the actual expelled gas is going down. So that kind of, all that together kind of causes that rocket to go straight up into the air. Okay, so hopefully that explained Newton's third law and action-reaction pairs. I may give you guys some questions on that, just kind of defining what is the action force and what is the reaction force. Hopefully that is helpful, and I'll see you guys in class.